When you think of planets, you might imagine rocky worlds like Mars or Jupiter with its many moons. But what about planets made mostly of diamonds? It sounds far-fetched, but scientists have found at least 2 planets that could be entirely composed of diamonds. These incredible rocks are rare even on Earth, where they're considered a luxury gem. But they're thought to be so common in space that there may be an infinite number of diamond planets out there. Researchers believe these magnificent worlds form when carbon atoms subjected to high pressure and temperature conditions crystallize. But where do the carbon atoms come from? Scientists think they originate from organic molecules that are prevalent in space and form when stars produce heavier elements through nuclear fusion. As these elements cool and combine in various ways, complex carbon-based compounds arise. When a large body of carbon atoms accumulates, they transform into diamond planets due to intense heat and pressure deep within their cores. The exact mechanism for this process is still under investigation, but the resulting planets can be thousands of carats in size, hence their name, super diamonds. One such planet is Kepler 442b, located 1,200 light-years away in the constellation of Lyra. This super-Earth has approximately double the mass of our planet and circles a K-type star every 112 days. In this video, we will discuss everything we know so far about the potentially all-diamond planet Kepler 442b. But before we continue, make sure you subscribe so you don't miss out on any future videos. Also, be sure to stick around until the end because we have another amazing video for you that you wouldn't want to miss. Alright, let's take a closer look at this intriguing world. Kepler 442b is a fascinating exoplanet that has captured the attention of scientists and space enthusiasts alike since its discovery in 2015. Located 1,224 light-years from Earth, this super-Earth has a mass of 2.36 Earths, making it about twice as heavy as our own planet. Despite its relatively small size, Kepler 442b has a significant orbital period of 112.3 days, which means it revolves around its host star once every 112 days. The star that Kepler 442b revolves around is a K-type star. Unlike our Sun, which is a G-type star, K-type stars are smaller and cooler, with a surface temperature ranging from 3,700 to 5,200 Kelvin. The star's mass is approximately 0.6 times that of the Sun, meaning it's much less massive than our own. This relatively small star provides just enough gravity to keep Kepler 442b in orbit without causing it to fly away into outer space. One of the most interesting facts about Kepler 442b is its distance from its host star. With an orbital radius of 0.409 astronomical units, it is significantly closer to its star than Earth is to the Sun. 1 astronomical unit, or AU, is the average distance between the Earth and the Sun, which is approximately 149.6 million kilometers. Therefore, Kepler 442b orbits its star at a distance of roughly 60 million kilometers. Being so close to its star may lead to intense tidal forces acting on the planet, which could have significant effects on its geology and atmosphere. The discovery of Kepler 442b was made by NASA's Kepler Space Telescope, which was launched in 2009 to search for exoplanets. The telescope uses the transit method to detect planets by observing the dimming of stars' brightness as planets pass in front of them. When Kepler 442b was discovered, it was already an exciting find, a super-Earth orbiting a K-type star. However, it wasn't until later that researchers realized its potential composition of pure crystallized carbon, aka diamond. Scientists have estimated that the planet's core could be composed of 80% carbon, with the remaining 20% consisting of other elements such as oxygen, nitrogen, and hydrogen. These elements are commonly found in planets with similar characteristics to Earth. While Kepler 442b is not a gas giant, it is believed to have a substantial atmosphere. The pressure and temperature conditions on the planet's surface could reach up to 5 gigabars and 6,000 kelvins respectively. These extreme conditions suggest that any diamonds on Kepler 442b would be humongous compared to the tiny ones we see on Earth. According to estimates, the diamonds on this planet could be as big as several hundred carats. Despite being a super-Earth, Kepler 442b is not a likely candidate for hosting life as we know it. Its proximity to its star may result in frequent volcanic eruptions and other geological events that could make the planet's surface inhospitable to life. Additionally, the intense radiation from its host star could also pose a challenge for any potential life forms. Nonetheless, the possibility of finding extraterrestrial life elsewhere in the universe remains an exciting prospect for astronomers and scientists alike. Currently, we don't have any direct images of Kepler 442b, as capturing images of exoplanets is quite challenging. Most images of exoplanets have been created using artistic renderings based on scientific data. More advanced telescopes, such as the James Webb Space Telescope, may provide us with better insights into the planet's atmosphere and surface features in the future. Analyzing the atmosphere's chemical composition could provide further evidence for the existence of diamonds on the planet. Studying Kepler 442b helps scientists better understand the formation and evolution of rocky worlds beyond our solar system. By analyzing its mass, orbital period, and stellar properties, researchers can gain insights into how the planet came to form and its potential habitability. Moreover, investigating the planet's atmosphere could reveal valuable information about its geological activity and internal structure. While Kepler 442b is not a promising candidate for hosting life, studying it helps us better understand the diverse range of exoplanets in the universe. Each planet has a unique story to tell about its formation and evolution, and by studying them, we gain a deeper appreciation for the complexity and wonder of our universe. The study of exoplanets has become an integral part of astronomy and planetary science. Astronomers use various methods to detect and characterize exoplanets, including the transit method, radial velocity method, and direct imaging. Once an exoplanet is discovered, researchers can analyze its atmosphere and surface features using spectroscopy and other techniques. The discovery of Kepler 442b has contributed to our growing knowledge of exoplanets and has raised exciting possibilities about the existence of diamond planets in the universe. Further study of this fascinating world may provide valuable insights into the formation and evolution of rocky bodies beyond our solar system. If you enjoyed this video about the diamond planet Kepler 442b, stay tuned for more updates on space exploration and scientific discoveries. Don't forget to like the video and share your thoughts in the comments section below. We'd love to hear your thoughts on this amazing planet and what you'd like to see covered in our future videos. Thank you for joining us on this journey of cosmic discovery, and we'll see you next time. You've probably heard Billie Eilish's song about it, but what actually makes this planet so special? Is it really made of diamonds bigger than grizzly bears? Well, let's start at the beginning. 55 Cancri E is a planet located 40 light-years away in the constellation Cancer. It was discovered in 2004 using the radial velocity method. This technique detects exoplanets by measuring the gravitational pull they exert on their host stars. As a planet orbits its star, the star's light will periodically change slightly in wavelength. This shift in wavelength indicates that the star is either moving towards or away from us, which suggests the presence of an orbiting planet. In the case of 55 Cancri E, the radial velocity method revealed a planet approximately twice the mass of Earth orbiting very close to its star. But it's not just its mass and orbit that make 55 Cancri E unique. Scientists believe that the planet's surface could be covered in diamonds larger than grizzly bears. But how did this happen? Well, it all comes down to the planet's composition. 55 Cancri E is primarily composed of carbon atoms, which are also the building blocks of diamonds on Earth. However, the conditions on this planet are unlike anything we experience here. 55 Cancri E is extremely hot, with temperatures reaching over 3,000 degrees Celsius. At these high temperatures and under immense atmospheric pressure, the carbon atoms on the planet's surface crystallize into humongous diamonds. But what makes these diamonds so special? Well, the size, my friend. The diamonds on 55 Cancri E are humongous, possibly reaching millions of carats in size. To put this into perspective, the largest diamond ever found on Earth weighed in at a mere 3,106 carats, so the diamonds on 55 Cancri E are truly colossal. But how exactly did they get so big? Well, scientists believe that the carbon atoms on the planet's surface are constantly being compressed and heated. This process causes the atoms to bond together and form larger and larger diamonds over time. But what evidence do we have that 55 Cancri E is actually made of diamonds? Well, not much, to be honest. Scientists haven't physically examined the planet, so all we have to go on is indirect evidence. For example, the planet's mass and its location near its star have led researchers to believe that it is mostly composed of carbon. But ultimately, we can't be 100% certain. Despite the lack of concrete evidence, the idea of a diamond planet is a captivating concept that has captured the public's imagination. The thought of walking on a planet made of giant diamonds is truly awe-inspiring. But unfortunately, any potential explorers would face some serious challenges. First off, the planet is located in a star system that is 40 light-years away from Earth. So getting there would take a seriously long time, even at the speed of light. Not to mention that the intense heat and pressure on the planet's surface would make it impossible for humans to survive for more than a few minutes. So while the idea of mining humongous diamonds on 55 Cancri E is a tempting thought, it's not exactly a viable option for Earth's diamond industry. But hey, who knows? Maybe one day technology will advance to the point where we can explore distant exoplanets. Until then, 55 Cancri E will remain a mysterious and captivating world hidden in the depths of space. It's important to note that while the discovery of 55 Cancri E has sparked excitement among space enthusiasts, it's still just one exoplanet among many. The true nature of the planet and its surface remains a mystery, and further study is needed to determine its composition and characteristics. Now check out another amazing video we have for you. It's a highly captivating topic that explores the boundaries of our existence.